Hello everyone, welcome to Equal to. In this video we are going to see the next set of in-text questions. In the previous video we saw about the states of matter. If you haven't watched it, I'll give a link here. You can go and check it out now. Because all these questions, these are based on the states of matter, so you must know those concepts before getting into these questions. Now if you have seen it, we'll get into these questions, and the first question is, arrange the following in order of increasing density. So we have given a list of things and we are asked to arrange these things in the order of increasing density, right? So before getting into the question, let us first see what density is. Okay, so the actual textbook definition for density is that the mass per unit volume of a substance. It is what we call density, right? The formula would be mass divided by volume. So what exactly does this mean, right? So generally how we calculate volume is like the measurement that we use is, it could be liters, it could be meter cube, something like that, right? So let us take liters. Let us take half a liter of volume, right? You assume a half a liter water bottle and fill it with water, right? And the same half liter water bottle, a similar one, fill it with iron beads, right? Or the ball bearings, right? Simple iron balls, fill it with that. Now both these water bottles have a volume of 500 milliliter, meaning half a liter, right? Both these have half a liter in volume. But when you weigh both these things, you'll notice that the bottle with water is significantly less in volume when compared to the bottle with iron beads, right? So what does this say? This says that when the volume is fixed, the material like being iron, it has more mass in the same volume when compared to water, and this is what we call density, right? Iron is significantly more denser when compared to water, right? So this is all about density. Now we are going to arrange these things in the order of increasing density. Okay, so out of all these things, air has the least density here. Okay, and the next thing is exhaust from chimneys. Why is exhaust from chimneys having higher density? Because it has toxic chemicals, right? So this is not the actual composition of air. It has some waste in it, right? So it has higher density when compared to air, right? And then comes cotton. Okay, and then we have water and honey. Like in this case you might be confused, right? How you consider cotton to be less dense when compared to water? The same thing that we have done already, right? When you take, let us say we think this in a different way, like you take 1 kilogram of water, meaning 1 liter of water. 1 liter of water weighs almost 1 kilogram, and you take the same amount of weight in cotton, right? You take 1 kilogram of water and 1 kilogram of cotton. You would notice that the 1 kilogram of cotton has so much volume. It's so big physically, right? But it weighs the same as the 1 kilogram water. That is 1 liter of water. Because like it's a property of water, right? 1 kilogram is actually 1 liter. So that is what I'm telling here. Okay. So this is what says us that the cotton's density is way lower when compared to that of water, right? So this is another way where you could see which element or which matter in fact has lesser density, right? You can compare its volume or its mass. You fix one and change the other. If you fix the volume, and you can see how the mass varies, and you can conclude that which one is denser, or you can fix the volume and see how fix the mass and see how the volume varies. And that is one more thing you could use to judge the density of something, right? And obviously honey is heavier, honey is denser than water. Like if you put a few drops of honey in water, you would obviously see that honey sinks down immediately, right? So honey obviously has higher density. And then chalk obviously it has higher density than honey. It's quite obvious. And then iron has the highest density of all these things. So this is for the first question. Now moving on to the second question. I know this table seems quite what do you say? Please don't mind it. It's quite simple. We'll get into these things, and like we are going to differentiate the characteristics of states of matter, right? You would have already learned about states of matter characteristics. If you haven't, please go back and watch that video first, because there is no point in learning this question without knowing those concepts, right? So coming to the characteristics of matter, we have three states of matter, right? Solid, liquid and gas, and we are going to compare these three states of matter based on the criteria, these characteristics, right? Okay, so the first characteristic is shape. Okay, so solids, as we know, they have fixed shape. Liquids, they don't have fixed shape, they take the shape of the container. And gas also have no fixed shape. And again, these are things that we have already learned very well in the previous video. So I'm just telling these, like we are just answering this question. We are not learning this now. We have already learned this. Okay, and the second thing is volume. Solids obviously have fixed volume. Okay, let us say you have a pen, its volume is not going to change. And liquid as well, they are going to have fixed volume. 1 liter of water is always 1 liter of water. But gas, they don't have fixed volume. They expand as much as possible. Like in a container, they fill out. Okay, and there are even more questions based on this that we'll see later. And gas, they expand. They don't have fixed volume. And coming to rigidity or fluidity, solids are rigid in nature, right? Obviously, we know that. But liquids and gases, they both are fluids. They can flow easily. And the next thing is intermolecular force. That is the force of attraction between the particles of matter. That is very high. It's at its maximum in solids. It is lesser in liquids, and it's very, very low in gases. Okay. And the next thing is intermolecular space. The amount of space in between these molecules. That is very less in solids because they are very closely packed. Liquids, a little more, like they are better than solids, meaning there is more intermolecular space in liquids, and intermolecular space is maximum in gases. They are very loosely packed. They have so much intermolecular space. They have maximum intermolecular space out of these three states of matter. And the last one is compressibility, right? Solids are negligibly compressible. So the compressibility is negligible, little to no compressibility. Liquids are reasonably compressible, and gases are highly compressible, right? We have so many examples are showing that gases are highly compressible. Okay, now moving on to the next question. I hope this is clear, right? You have to, it's quite obvious. There is no need for you to worry about it or memorize it. It's very simple. It's very obvious. You'll know these things very well. You just have to tabulate them, right? So these are the different characteristics of states of matter. Moving on to the next question. Comment upon the following. Okay, so we are given a few terms and we are going to see what those terms are. The first one being rigidity. Okay, so what we have seen? We have seen that solids are rigid. And why are they rigid? Because they have the tendency to maintain or retain their shape. Even when a strong force is applied, they tend to maintain their shape, and only they break when when excessive force is applied, right? So this is rigidity, tendency to maintain its shape. That is what we call rigidity, right? The next thing is compressibility. Okay, so we have seen this in the case of air and like gas and liquids, right? They are compressible. When external force is applied, the volume gets decreased. So what exactly happens? In case of air, we'll take air. There is so much intermolecular space in between the particles of gas, right? So when you apply pressure on it, that intermolecular force gets decreased. Like when you apply force on it, the intermolecular space gets decreased, and that is how we are able to compress gas. And it applies for water as well. Like that is liquid as well, right? So when external force is applied on the particles of matter, its volume gets reduced, and this is what we call compressibility. These particles, these individual particles, they are brought closer together. This is what we call compressibility. The next thing is fluidity, the tendency to flow. Okay, in case of liquids and gases, the particles, they have kinetic energy, right? And they don't have fixed volume. They can move around, right? In the case of gases, they don't have fixed volume, but in case of liquids, they have fixed volume. But even then, the particles have energy and they have a reasonable amount of intermolecular space, right? So they can move around, and that gives them the tendency to flow. Since these particles have spaces in between them and they have higher kinetic energy, they can flow, and that is what we call fluidity, tendency to flow. The ability to flow is what we call fluidity. And the next thing is filling a gas container. Okay, so let us say we take compressed gas, right? We take 1 ml of compressed gas, and what we are going to do is that we are going to put it in a container. Now what will happen? Since gas particles have so much kinetic energy, they dash with each other, they hit on each other, they move rapidly, and they occupy the entire volume that they can maximum occupy, right? If we put 1 milliliter of gas in a plastic container, and let us say the volume of plastic container is 500 ml, this gas expands rapidly. Okay, so these gas particles, they have high kinetic energy and they expand rapidly throughout the volume of the box, right? So the entire box gets filled with gas, and that is what you can see. Like, it's a very simple picture that I've created, but this basically is the concept. Even if you use a small amount of gas, it will rapidly expand because of the high kinetic energy, and it will occupy the entire volume of the container. Next thing is shape. Okay, and the shape of matter is basically depend on the intermolecular force, right? In case of solids, they have high intermolecular force of attraction, and that is what keeps them rigid. That is what gives them the tendency to stay with their shape. They don't reform because they have high intermolecular force. In case of liquids, they have relatively low intermolecular force, so they take the shape of the container they are placed in. In this case, we see a milk carton, right? And it's quite cuboid in nature, and the milk that is stored in it will be in that shape. But in case of gases, they occupy the entire shape. You cannot see that they have a shape, right? Gas don't have shape, liquids don't have shape, but they assume the shape of the container, and gas expands completely, and it takes the maximum volume it can possibly have. And all this is due to the intermolecular force that is present in between the particles of this matter. Okay, the next term is kinetic energy. So if a particle has to move, if something has to move, it needs to possess some energy, right? And since these particles move, they have something called kinetic energy. It is the energy that particles possess, and that is responsible for the motion of these particles, right? Molecules of gas, they vibrate rapidly, and they hit each other, and that is why they have maximum kinetic energy, and that is why they fill easily. Like in previously we saw, right, 1 milliliter of a gas fills rapidly the entire container. Since they have high kinetic energy, they move very fast. These particles, they move very fast and expand in volume, right? This is what we call kinetic energy, the energy that these molecules, the particles of matter possess, and that is responsible for the motion of these particles, right? And density, this is something that we have already seen. Mass per unit volume is what we call density, and density is equal to mass by volume is the formula. It's quite simple, right? And we are moving to the next question, and this is give reasons. A gas fills completely the vessel in which it is kept in. Okay, we have already seen this. It's the same repeating concept right from the previous episode. Everything is related. Okay, so the gas particles, they have high kinetic energy, so these particles move rapidly, and that is why they fill the entire container. They move in all directions. They have high kinetic energy and less force of attraction between them, so they can move rapidly and move in all directions, and thus they can fill the entire vessel within few seconds, right? So this is the reason for that. Kinetic energy being the main point. The next thing is gas exerts pressure on the walls of the container. This is just a continuation of that. Since these particles have high energy and move in random directions, they vibrate very fast and they hit on each other and they hit on the walls of the container as well. Since these gas particles hit on the walls of the container, there is pressure exerted in these walls, and that is why, like, obviously, I think I have finished what I have to say. Pressure is exerted on the walls of these containers because these gas particles, they have high kinetic energy and they move rapidly, they vibrate. Okay, that is why there is pressure exerted at the walls of this container. Okay, the next question is, we have to give reason why table should be called a solid, right? I think it's quite a lame question. I don't know why they have it. Table is obviously solid because it is rigid, it doesn't change its shape. The particles are very tightly packed and very high intermolecular force of attraction. If you apply force on it, it will try to remain within its shape, and if you apply excessive force, it will obviously try to break, and all these things are characteristics of solid. So obviously a wooden table is a solid. Moving on to the next question, we can easily move our hand in air, but to do that same through a solid block of wood, we need a karate expert. Why is that? Okay, these questions may sound lame to you, but then please bear with me. These are the questions from Intex, and it might give you a better understanding of those concepts, right? Okay, so we'll go on to this. Moving your hand through air. Just try moving it, just for fun, right? I am moving it now without even my knowledge. Okay, so moving your hand through air, it doesn't need any energy, right? I mean, what I'm trying to tell is that you can move them easily. There is negligible amount of resistance to it, but you cannot move your hand through wood, right? Why is this? The particles of air, that is the gas particles, they have, again, the same reasons, the characteristics of solids, no, the characteristics of states of matter, the same reasons repeat again and again in all these questions. These particles have large intermolecular space between them. These particles have low intermolecular force of attraction between them, so you can just slice through it. Okay, and compared to this, liquids have more intermolecular force, intermolecular attractive force, and less space, no, so it will be relatively harder for you to put your hand through water, right? It's very easy on air, it's relatively hard on water, and it's quite impossible on wood because they have very high intermolecular force of attraction and they are very closely packed. You cannot just slice your arm through it, right? So if you give it excessive force, it breaks, and that is why they need a karate expert to do that. Okay, so this is the reason for this. Now moving on to the next question, liquids generally have lower density as compared to solids, right? Right. But you must have observed that ice floats on water. Find out why. Okay. We already saw, right? When seeing density, we saw when the same amount of volume is had, we compare the weights to see which has more density, right? We generally think that solids are more denser when compared to liquids. That is our general assumption, right? Iron obviously has more density when compared to water, and iron obviously sinks in water. It doesn't float, right? So why does ice floats on water? This is the reason that they are asking. Okay, so the reason being, ice internally has a like you have an image, right? The one on left, it shows the internal structure of the molecule of ice. Okay, you could see that there are diamond shaped patterns, right? These patterns, they are actually formed and they have spaces in between them. It's not entirely ice. They have some space in between them that are free. Okay, maybe air pockets. Okay, so this is what makes ice less denser when compared to water. Since although solids generally have high density when compared to liquids, ice actually has lesser density when compared to water, and that is why ice can float on water. Okay, And you might also see iron has more density when compared to water, but ships that are made out of iron actually float. Why? Because when you compare the entire ship, you have a lot of air spaces in between them, right? It's not like the entire ship is casted out of iron. You have a lot of air space in between them. You have space to store goods. You have everything in between, right? So when you compare the density of the overall ship, it would be lesser when compared to the density of water, because you have a lot of air space in between them. Okay, so the overall density is far lesser when compared to that of water, and that is why iron ships float. And that is similar to the property of what you say, ice, right? Because they have air pockets in between them. It is not completely ice, right? Okay, in this image you can see there is space in between them, and that is what is the reason for ice having lesser density when compared to that of water. Okay, that is all the in-text questions, and that is all for this video. If you have any doubts or questions, please post them in the comments and I'll get back to you as soon as possible. I hope you liked this video. If you haven't watched the theory yet, you should have watched it far before this video. Even then, watch all those videos, and thank you so much for watching this video. See you on the next video. Bye for now.